All right, let's start things off. Hello, everyone. My name is Lance Zurich, and I am the product manager for the Fischer Technic division over here at Studica. And today I'm going to give you a brief overview of the Fischer Technic STEM Prep 2.0 and STEM engineering sets. Now, these sets were designed to enable educators to provide students with a project-based, standards-focused curriculum program involving inquiry, design, and problem solving. The curriculum for each of these sets was created especially for Fischer Technic by noted educator and STEM expert, Tom White. So we're going to begin the webinar with the question, what is STEM education? I will tell you that every time I think about omitting this from a webinar presentation, thinking that everyone's heard about it, somebody always asks, so I leave it in. For most of us, we're well aware of what STEM education, of course, refers to. The letters in STEM are an acronym which refer to science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education, you probably really can't open your email box without seeing STEM highlighted in the subject line of at least one of your daily messages. And you certainly can't read an educational journal or visit an educational conference when we are able to do so without being bombarded by references to STEM. And the reason for this is, of course, really pretty simple. To quote the Bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education is necessary because it helps provide the scientists and engineers needed for future development, provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered a matter of national security. On every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us, both as individuals and as a nation, to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments occurring all around the globe, where countries such as China and India are making major investments in state-of-the-art infrastructure. And of course, while all this is well and good, and while we should all strive to be good citizens, many students might instead ask, well, what's in it for me? Why do I want to study engineering? Or why do I want to study coding? Or what have you? So let's consider what it means on an individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. And these projections indicated that STEM occupations would grow by 17%, compared with just 9.8% growth for all other occupations. In March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which took a look at how those numbers played out up to the year of 2015, with 3 years still left in the initial projection for this program. Now, what they found at that time was that while the projected STEM growth up to that point again in 2015 was as expected, up significantly, albeit slightly less than they were going to expect to reach in total by 2018. So what they found was that it had reached an increase of 14% compared to the full 17% that they were expecting in the next 3 years after that. But compared to that, the actual growth for non-STEM jobs, which again, they expected by the time they would reach 2018 was going to reach a full 9.8%. At this point, it had only reached a fraction of that, 1.7%, which is a stark difference. Now, here's a statistic I like to share that should give anyone entering the job market of the future pause, and this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. As Chesloff goes on in the article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, going back to the STEM Jobs 2017 update released by the US Department of Commerce, which I referenced a few slides ago, here are 3 key points mentioned in this report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point 1, STEM workers command higher wages, earning on average 29% more than their non-STEM counterparts in 2015. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs. And these would be, of course, things we think of first, like being a scientist or an engineer. To quote the report again, STEM degree holders enjoy higher earnings, regardless of whether they work in STEM or non-STEM occupations, end quote. Now, there was a video that I saw recently on YouTube, which was posted by the Women's Forum for the Economy and Society. And the title of that video really summed up things pretty nicely, I think. And the title of that video was, "Every Company is a Tech Company." Essentially, what students want to keep in mind is that whatever a company makes, sells, or whatever service it performs, at some point, STEM skills are required to help that company fulfill their mission. Moving right along to key point number 3, and that relates to job growth. Quoting the report again, employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively. And STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations, end quote. With all of this in mind, the trick for educators is to find methods for getting students involved with STEM, and in particular, the most highly in-demand, technology-focused skill areas. These are things like engineering and coding, and getting students involved in a way that engages the students' interest and creativity, while at the same time developing the work habits, the way of approaching problems, and the skills that they will need to draw on as they move forward in their careers, both academic and in their working lives. Most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. They do this through experimentation, research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on project-based learning. And that brings us to the focus of the webinar today, which is the Fischertechnik STEM Prep 2.0 and the STEM engineering sets. Both of these sets have been designed to provide a guided, project-based learning experience complete with detailed, standards-focused curriculum using the unique Fischertechnik building system. So that probably brings up the question, well, what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides. And in this way, it allows for almost limitless design possibilities. Many of the other parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will also help students to address very specific design needs. Fischertechnik was originally developed back in 1964 by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had made during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, and he was also the creator of the expanding nylon wall plug. You see him holding an example of it there, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as various components used in the automotive industry. And they also provide consulting services in regards to various manufacturing processes. We would also like to mention that Fischertechnic was the very first construction set to offer students the ability to build and program their own robotic creations using the original pre-Macintosh era Apple computers. Almost since its inception, Fischertechnic has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related subject matter, things such as robotics, renewable energy, mechanics, optics, physics, pneumatics, and much more. Fischertechnic has also been used by numerous companies, including companies, like Porsche, Daimler Chrysler, and BMW, just to name drop a few, for industrial simulation and training purposes. Now, in addition to this, over the last few years, Fischertechnic's line of pre-assembled simulation models have found widespread adoption for demonstrating and exploring the world of IoT, which is also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, as such, more than being just something that students are only going to use for a year or two in their development, Fischertechnic is really designed so that students can grow along with it. Essentially, as students progress through their academic careers, they can also progress through the levels of Fischertechnic education solutions which are available. The Fischertechnic STEM Prep 2.0 and STEM engineering sets are two of the most important members of the Fischertechnic education family. STEM Prep 2.0 is designed for exploring essential aspects of technology with a focus on physics, robotics, energy, and power. STEM engineering is designed to provide a comprehensive overview of robotics, coding, and automation systems. Each of these STEM focus sets is designed to provide all of the materials you will need, both the physical and the instructional materials, to enable teachers to offer a complete, daily, STEM-focused classroom experience. STEM Prep 2.0 contains over 75 academic hours of curriculum material, and STEM engineering contains over 150 academic hours of curriculum material. So essentially, if you offer your students a STEM education class of a single 50-minute period each day, 5 days a week, this would provide you with enough curriculum material with the STEM Prep 2.0 set to cover half a year, and with the STEM engineering set to cover a full academic year. The curriculum for each set comes in a handy PDF format. There is a curriculum PDF for the teacher to conduct the class, and also a separate PDF that can be shared with students, acting as a guide for the class activities and helping everyone to stay on the same page. And to assist new users of the Fischertechnic system, the curriculum also includes a helpful tutorial section. This section provides guidance on identifying the many types of parts included, shows how those parts fit together, and walks users step by step through the building of a basic model. The STEM Prep 2.0 and STEM engineering sets are also designed to be somewhat dual function. Besides being designed so that educators can conduct a curriculum-centered, project-based STEM class, they also include full-color step-by-step assembly manuals in PDF form from popular Fischertechnic STEM education sets. Now, these assembly manuals can, of course, be used as a reference when students create their own original projects, as they will be asked to do during the course of both sets of curriculum. But they also allow you to build all of the models shown in each manual with the parts included in each set. In fact, the STEM engineering set allows you to build all of the models found in Fischertechnic's 3 most popular robotics sets. And the STEM Prep 2.0 allows you to build all of the models found in 8 different STEM education sets, as well as the robotics BT beginner set. And we're going to discuss this in just a little bit. Now, as I've mentioned a couple times during the presentation, the curriculum material found in the Fischertechnic STEM Prep 2.0 and STEM engineering sets was created by a man named Tom White. Then you see Tom over here on the slide. Tom is a noted educator who's been involved in STEM education since the 1970s, and he's known for designing programs for educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this is not the first time that Tom White has created curriculum around the Fischertechnic system. Besides also being the creator of the curriculum used in our elementary focused introduction to STEM series, and our other project-based offering, which is the robotics competition set, both of which are the subjects of their own webinar presentations if you so choose to attend those. But Tom has incorporated Fischertechnic in many of the educational programs that he's been involved with designing over the years as well. Now, I've talked to Tom many times about this, and he's often said that he believes that Fischertechnic is the ideal construction set for any kind of engineering-based curriculum program, and he's given several reasons for this. First, he really likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. He likes the versatility of Fischertechnic and the fact that it offers so much more economy than purchasing an expensive piece of equipment, something, for example, like a robotic arm, where you might use it for a few experiments, but then it sits on a shelf till the next semester. And he also appreciates that the Fischertechnic system, with its wide assortment of, again, very specific mechanical and structural parts and components, offers almost limitless creative opportunities for engineering students. The curriculum for both the STEM Prep 2.0 and STEM engineering sets has been designed to address some of the most widely recognized academic standards which are currently in place. This includes the college and career readiness standards for math, science, reading, and writing, the NSES content standards, the standards for technological literacy, the ISTE Foundation standards, and the next generation science standards. When Tom White put together the curriculum for these two sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, I know in conversation he's mentioned that he sees his own strong point as being in the creation of curriculum such as we're talking about now, more so than, let's say, conducting a lecture himself. So with this in mind, he focused on creating a curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing the class so that they could instead focus on the needs of the students. Now, the material has been included at the beginning to familiarize new users with how the system works, as I mentioned before, and each section of the curriculum clearly spells out how things will be covered in that unit. Essentially, this was designed to be a turnkey solution, so you don't need any special training or what have you. Everything is laid out right here, and it's going to provide everything teachers are going to need in one place. So in short, the curriculum was designed to provide a clear roadmap for both teachers and students, with the learning facilitated through the extensive use of projects and problems for the students to address. The goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. The detailed curriculum with each set, if followed, will allow educators to provide what is essentially a standalone project-based STEM education class. Now, of course, as I mentioned before, each set also includes the step-by-step instructions for building the models found in various topic-focused Fischertechnic STEM sets, so you could also take that approach as well if you wished. Now, under this project-focused model used in the curriculum, students are told upfront what they will need to learn and understand. They are given a real-world scenario where they have to take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to. And they are then provided with different tools and pathways to help them achieve this goal. Now, among other things, students will be asked to perform research, and this is research both inside and outside of class. And they learn the documentation process, and this will include things like creating a design brief, maintaining a digital engineering journal, and so on. Students will also be required to collect data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data, how to put data into graphs and other formats, and so on. Students are given a technical literacy task driven by the project. Fulfilling this task will require the students to gain the knowledge and the tools they need to address it, again, through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and technical-based skills needed to successfully address the project. They will devise solutions to their tasks and create prototypes, again using the advanced Fischertechnic modeling system. When required, students will also create and install the programs needed to control these prototypes. They will document every step of the entire project and formally present their findings, including a live demonstration of the prototype in action. Now at this point, let's look at the sets themselves. And we're going to begin with the Fischertechnic STEM Prep 2.0, the box of which you see on your screen now. The prep in the name, like the word STEM, is an acronym. And in this case, it stands for Physics, Robotics, Energy, and Power, which are the subjects focused on in the set. Each set is designed to be used by a team of 2 students at a time. The set itself contains 2,260 parts and components, including the Robopro LT software, the BT or Bluetooth smart controller, an electronic module, a pullback motor, a solar motor, an XS motor, a mini motor, a compressor, 2 solar modules, a gold cap energy storage unit, an NTC resistor, a phototransistor, an LED, 2 rainbow LEDs, and many, many more parts, all of which come packed in a sturdy plastic Ratnell's storage box. The project themes addressed in the STEM prep set include the following: sketching and documentation, simple machines, mechanical systems, structures, the conversion and the storage of energy, electronics, optics, digital communication, and programming control systems. And once again, the curriculum for the STEM Prep 2.0 is designed to provide enough material to cover approximately 75 plus academic hours. The STEM Prep 2.0 set also includes step-by-step pictorial instructions culled from 9 individual Fischertechnic sets. You'll see them listed over here. There's a set on drive systems, eco-energy, dealing with, of course, renewable energy, wind, water, and sun, pneumatics, mechanics, physics 1 and physics 2, the electronics set dealing with circuits, optics and light, and the robotics BT beginner. Now, I will mention that aside from 5 models shown in the instructions for the eco-energy set, which do incorporate an optional fuel cell add-on, which can of course be purchased separately, it's not included in this set, but all of the other 118 models shown in these collective instructions that you see on the screen right now can be built with the parts found in this one set. Now, as such, with this in mind, even if you didn't wish to use the curriculum for whatever reason, the STEM Prep 2.0 set would still be a convenient and very affordable way to have the building and learning options from those 9 sets in one box. Next, we're going to look at the Fischertechnic STEM engineering set. Now, this set, which can be used as a follow-up to STEM Prep 2.0, or it can be used entirely on its own, is designed to provide students with a comprehensive overview of robotics, coding, and automation systems. The set is designed for use again by teams of 2, but in this case, even possibly up to 4 students at a time. Now, the difference here between this and the other set, where I said the other set was only 2 students at a time, and this one is 2 to 4, is because the projects being constructed in this with this set are going to be much more elaborate, and they're going to involve many more steps than those found in the STEM Prep 2.0 curriculum. And with this in mind, it's easier to keep a higher number of students actively engaged with all the research, the building, the programming, and all the other activities which will be required. This set contains 890 parts components, and this will include things like the Robopro software, which is graphic programming software, the robotics TXT controller with its full color touchscreen, Bluetooth, Wi-Fi capability, what have you. Fischer Technic AccuSet, which is a rechargeable battery pack and a charging unit. It includes 2 encoder motors, a compressor, 2 phototransistors, 2 XS motors, a mini motor, 6 push button switches, a color sensor, an NTC resistor, 2 LEDs, 2 solenoid valves, a vacuum suction device, and once again, hundreds of other parts, all packed again in a sturdy Gratnell storage box. The project's themes in the curriculum for the STEM engineering set address the following topic areas: sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. And again, as you see on the screen, the curriculum is again designed to cover 150 plus academic hours. Now, there are also activities included to address the following areas that may come up during the course of the curriculum. There are sections on sketching, schematics, Ohm's law and power, an introduction to using the Robopro software and using the TXT controller, working with flow charts, open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, subprograms, data, working with sensors such as the digital switch and the digital phototransistor, analog sensors such as the NTC resistor and the color sensor, an introduction to the camera attachment, using the camera to detect motion, using it for color detection, creating a ball finder, which involves using the camera as a vision system on the robot, working with the line tool and the encoder motors, building the control panel, working with pneumatics, with robotic positions, recording the positions, and utilizing existing programs and subprograms. And this set also includes the step-by-step assembly instructions found in the following 3 Fischertechnic robotics sets, which you see on your screen now: the Robotics TXT Advanced set, the Robotics and Electro-Pneumatics set, and the Robotics in Industry set. So once again, even if you wanted to work, if you did want to work outside of the curriculum for whatever reason, this set will still contain all of the parts, the software, the controller, the power supply, all the other components, so that you can build any of the 22 models found in these 3 sets. And this will include things like color sorting machines, pinball machine simulations, mobile robots, robotic arms, and much more. Now, at this point, as we've touched upon what is covered by each set, I think it's going to be most useful for everyone to show you how the curriculum for the STEM Prep 2.0 and the STEM engineering sets are structured. Each unit of both the STEM Prep 2.0 and the STEM engineering curriculum contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. To put this into better context, we're going to look at the curriculum that accompanies the STEM engineering set. Now, just to mention, while we're going to focus on material found only in this particular set for the purpose of the presentation, the structure of the units and how subjects in each of these sets are addressed is essentially the same for both. So when you see me mention different things about how the units are structured, keep in mind that would be the same way that the units are going to be structured in the STEM prep curriculum. We're going to start off with the curriculum, or with the table of contents here. And the first thing I'd like you to note is that before we get into the specific units, and if you look closely, you're going to see on this page, we have units on sketching and documentation and the unit on basic electricity. But before we get into any of that, there is a section again that's designed to help new users of the Fischer Technic system to quickly get up to speed. Again, the core building block used in the Fischer Technic system is designed to attach from all 6 sides. And many of the other parts are designed for very specific purposes. Now, with all of this in mind, and as the building system is a little bit different than the simple stacking construction of many other building sets, we've included this section right up front to increase your comfort with the system and to allow both you and your students to get the most from your building experience. There is going to be a section showing you how the various parts of our parts fit together, and discussing the pin and groove assembly method. There's a section showing you how to identify the different parts from the core blocks to more specialized parts such as clip axles, the girders, rivets, angle pieces, and much more. There's a section that shows you a picture of every part contained in each set, along with the name, the part number, and the quantity of the part that are included. Now, this can be especially useful if you ever wish to order additional quantities of any parts to add to your assortment and just, helping you to better identify everything. And for those educators who are new to an approach such as we're using here, there is a chapter discussing specifically how to go about conducting a project-based STEM education class, because it does have some differences from teaching a normal class. Now, on that note, we're going to jump right into a sample unit just to explore the structure that we discussed. Now, this unit, as you will see from the image on the screen now, is focused on programming. The picture that you see at the top of the sample page is a graphic representation of the Robopro software that's used. And as you see in this close-up here, Robopro is designed to utilize icons that represent the different actions the robot must perform, which students, of course, arrange in a flowchart style manner to create the program for each robotic model. Now, the nice thing about using graphic programming software such as Robopro for programming is that it allows students who may not have any prior experience with programming of any sort to quickly become comfortable with doing so. But at the same time, it also helps to familiarize them with the core concepts that will be found in all types of programming. Now, going back to our main page, as you will see, right under the unit title, the first thing that we will encounter in each unit is a section entitled "The Purpose of the Project." Now, this is the section that seeks to clearly spell out to students the answer to that eternal question, why are we doing this? See, too often in the past, students might encounter subject matter that didn't seem to have any relevance to them. I know myself back in high school, it would have been something like trigonometry. Well, in this case, students are told why the material is necessary and then why it fits into a larger scheme of things and what we're going to hope to develop here. Next, we will see the concepts to be addressed in the unit. And these can be thought of as the big ideas that students should take from this project that will be essential for them to understand and utilize, not only today, but hopefully to draw upon as they move forward in STEM fields of study and possibly STEM-related careers. Following this, we get into the outline. And in this section, we drill down more specifically to what will be addressed in this unit. Now, as this particular section, again, is focused on programming, you will see that we touch upon areas such as the methods for writing programs, for example, flowcharts or word problems, working with program characteristics, for example, open or closed loop, working with branching, things like digital, analog, subprograms, and so on. Then we come to the section where each of the specific standards to be met by this particular project unit are spelled out, which of course provides the educational justification for the projects themselves. Now, because it's impossible to include all of the standards that have been created by individual states and school districts, what we've done instead is to select the most universally accepted standards that are currently in place in the United States today. With this in mind, we begin with the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. Next, we have science standards, beginning with the NSES content standards for K-12, the standards for technological literacy, which are followed by the ISTE Technology Foundation standards for students, and the next generation science standards. After this is the assessment section, which includes links to both general course rubrics as well as rubrics related to the specific unit. After that, we have the essential question. And this can be thought of as the broad major idea to be explored in this particular unit. Now, in this case, the question being put forth is, how can we make decisions electronically and remove the need for human intervention? And that's going to be addressed with what can be considered the centerpiece of each unit, which is the next thing we will see, the student scenario. The student scenario for each unit gives the students an opportunity to explore the unit's essential question, and this occurs in the form of a real-world problem that students are given to solve, which helps to provide the tangible example of why the subject matter being explored is both relevant and important to understand. Now, in this particular example, again taken from the programming unit, students assume the role of a controller/programmer working at a programming company that happens to specialize in designing elevators and writing the control packages for their clients. Students are going to be, of course, working in small groups, which again is the way all projects are approached in this curriculum. And the students are going to be asked to work together to design an elevator that will have certain parameters and which must be able to perform certain functions. Now, one example would be that the elevator, if, for example, the elevator was at rest on a middle floor and someone were happen to push a call button on a lower floor at the same time as another person pushed a call button on a higher floor. What students are going to be asked to do essentially is to create a protocol in the programming to address which call button the elevator answers first. Just one example. Now, again, in this student scenario, the client requirements are all spelled out, and the students will be required to, again, design an elevator, create a program to address these specific requirements, build an actual elevator prototype using the Fischertechnic system, and eventually prepare a presentation for their fictional clients that includes a demonstration of the prototype and the program they've created in action. The student scenario is followed by the daily plan. And again, the daily plan acts as a roadmap of sorts, clearly laying out the expectations as students work through the project in the student scenario. Each day of the plan acts as a guideline to spell out specifically what the students will look at today and what they're going to need to accomplish. You will see that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, they will have links showing them what will be required in a design brief, or what they'll be asked to create again, or what kind of information they're going to need to track in their digital engineering journal. Or, for example, how to install and use the Robopro programming software. And we're going to look at some of these links in just a little bit. But getting back on track, each day of the plan contains a different task to be addressed, a different activity to perform, or a different question that needs to be answered. Now, for example, if you look closely at the bottom of the page here, which is, I've got day 7 up right now, you'll see that I have a discussion topic listed, which is, how does my dishwasher know when the dishes are clean? Well, of course, as we all know, a dishwasher doesn't judge or comprehend when dishes are clean, but instead it's been programmed a certain way to go through certain cycles for a specific period of time. So in this case, the teacher can lead a discussion in which this idea can be explored. Now, other things covered in this unit, for example, will include things like how data is taken from a sensor and recorded, or how files can be taken from the Robopro programming software and put into an Excel format to be worked on, and then taking that and putting it back into the Robopro format. For example, working on robotic positioning and a lot more. Now, all in all, this is one of the longer units in the curriculum, continuing for a period of about 35 days total, if we once again use that 50 minutes a day, 5 days a week analogy. Now, in any case, as students work through their daily plan and on the answer to their student scenario, once again, they're going to be required to perform research. They will be required to do trial and error experimentation. And again, they have to document the entire process. And this means maintaining a design notebook and a digital engineering journal, both of those things. They're going to design and build a working prototype, again, using the Fischertechnic system. If the model is automated or robotic, as it is in this case, of course, with the automated elevator, then students will also have to design the program that controls the model. Now, putting everything together, each student group, again, as I've mentioned a few times, will at the end of each of these units create and deliver a presentation of their prototype in action. The idea overall is that each day builds on the day before, and each activity is subsequently more complex, and along the way provides more of the information that students will need to draw on to successfully complete the project at hand. And the idea here is that it really helps to reinforce the concepts, and it ties everything together in a very organic and meaningful manner. Now, there are also various supplemental materials included at the end of each unit, and depending on the unit, this can include vocabulary words, carefully selected web-based resources, Word documents, PDF files, and PowerPoints. And once again, each unit of the curriculum for both the STEM Prep 2.0 and the STEM engineering sets follows the same structure as we've just seen, including the standards, the rubrics, the daily plan, the resources, and so on. And as I mentioned before, there are also numerous links that show up throughout the curriculum that are designed to provide more guidance on specific topics as they come up. Now, besides being linked in this way throughout the curriculum, these sections are also collected in one place at the end of the curriculum. Once again, using the STEM engineering curriculum as our example, there are links designed to provide detailed information on things such as what's required in that design brief, or what's required in an engineering notebook. There's a section on schematic drawings, another section on Ohm's law and power, how to program a robot to detect motion using the camera attachment, working with digital branching, working with flowcharts, open and closed loop programs, combinational logic, working with Robopro, robotic positioning, working with sensors, working with data, using vision systems, subprograms, and so on. And there is also a section where all of the rubrics for the curriculum are collected, and this of course includes both the general course rubrics as well as the specific rubrics for each individual project theme unit. And finally, this is followed by a section containing the step-by-step assembly instructions, which I mentioned. And once again, the STEM prep curriculum will share the same structure, just with a focus, of course, on some different subject areas. Now I'd like to share a few photos with you of one of the schools that's been using the Fischertechnic STEM Prep 2.0 and STEM engineering sets. And this particular school is Westfield Technical Academy, which is located in Westfield, Massachusetts. And the program at Westfield is being conducted by Dave Roberts, who is their science teacher. Now, what you see in these pictures are the students as they address the first hands-on challenge presented to them in the curriculum for the STEM Prep 2.0 set. And that is the challenge of designing and building a prototype of a braking system, as you might find on a racing bicycle. As you see, students work in small groups. Again, with the STEM Prep 2.0, we would really recommend one set per each group of 2 students. But with STEM engineering, again, because the projects are much more involved, you could expand this group from 2 to up to 4 students at a time. Now, as you can see from these photos, while the students are all working on the exact same project, there is no one right way. There is no single solution for addressing the design challenge and given in each unit student scenario. So some of the students will, of course, build prototypes that work smoothly and efficiently, and others will create models that clearly need more refinement to really be practical. But the goal in any case is, of course, to see how well students synthesize all the concepts they've learned and how working in small teams, how well they can use their creativity and problem-solving skills to make something that will most effectively and efficiently answer the criteria given in the student scenario. Now, I'd also like to mention another benefit of the STEM prep and STEM engineering sets, albeit a somewhat unintentional one. A large segment of the students at Westfield Technical Academy are what are classified as ESL students, which is, of course, English as a second language. And in this case, they originally came to the US from Russia and the Ukraine. Now, in Massachusetts, teachers are required to take classes in ELL, English language learning, to help meet the needs of students such as these. Now, Dave Roberts, who, as I mentioned before, is the teacher in charge of the Fischer Technic STEM programs at Westfield, told me that he has attended 3 different ELL training classes. And all 3 of these ELL training classes have highlighted in particular project-based learning as an important tool for ESL students. The reasoning here is because design is really seen as sort of a universal language. And working through the curriculum in this hands-on fashion helps to not only teach the students essential STEM-related concepts, but also at the same time, it aids in building their English language skills because it helps to make the connection to actual processes and actions they can understand. Now, again, what I've shared here are just a sample of some ways that students could address this particular design challenge. And as I've stated before, each subsequent unit will require more sophisticated designs, and each will build on what has come before. So just to quickly summarize what we've covered up till now, each Fischertechnik STEM Prep 2.0 and STEM engineering set contains everything you will need. Again, that means all the parts, all the software, all the assembly instructions, and complete day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and we would hope for many years after that. There are no additional fees, there are no subscription charges involved. Everything you need is included. And again, as I mentioned, it's all reusable. Students can build a model, perform the experiments, take it apart, and build another one. And of course, if you ever did need any odd spare parts or replacement pieces, you can purchase those pieces individually in whatever quantity you choose directly from our website. Again, the Fischertechnik STEM Prep 2.0 and STEM engineering sets are designed to make it easy for educators from any kind of background to offer a hands-on project-based learning experience to their students. And again, this is what experts agree is one of the most effective methods known for teaching STEM education concepts. Again, here we have the STEM Prep 2.0 set, which comes with over 2,200 parts and components, day-by-day project-based curriculum PDFs for both students and teachers, including over 75 academic hours of material, as well as the step-by-step assembly instructions from the 9 popular Fischertechnik education sets for building 118 different models. On this set, pricing starts at just $899 per set, and of course, classroom pricing is available upon request. You just contact one of our reps for a quote, and they'll be happy to get you that. And here is the STEM engineering set shown here, which includes 890 parts components, and this includes the programming software, the full Robopro programming software, the full color touchscreen TXT controller, sensors, motors, and so much more, as well as, again, the student and teacher curriculum PDFs featuring over 150 academic hours of material and full color step-by-step assembly manuals from the 3 most popular Fischertechnik robotics sets. The pricing on this set starts at just $939 each. And again, please contact us directly for classroom pricing. So at this point, if we have any questions, this would be a good time to feel free to ask them. I have found that the easiest way to do this is just to use the chat windows or the question and answer windows on the Zoom toolbar, because sometimes we get too much interference and what have you when we open up the phone lines. So what I would say, if you do have any questions, feel free. Again, either the question and answer window or the chat window, feel free to type in anything you might have. I will give it a second if I don't see any words coming through, because I know sometimes people feel like I've touched on everything, and sometimes people might want to ask them things directly, in which case I will give you my email address in just a minute as well. So questions going once, questions going twice. Okay, well, on this note, I'd like to thank everyone for taking the time to attend today. Now, if you would like to know more about either the Fischertechnik STEM Prep 2.0 or the STEM engineering set, if you would like to request a quote, if you'd like to speak to your dedicated educational representative, depending where in the US or Canada you are, you can call us at either of the numbers that you see on the screen now. Now, in the United States, our toll-free number is 888-561-7521, or if you're in Canada, you can reach us at 800-561-7520. In either case, you call either of those numbers, we will put you directly in contact with the rep who handles your region, whether you're in Utah, Saskatchewan, New York State, what have you. We will put you in touch with your dedicated educational representative. Now, you can also find more information on both of these sets, as well as all of our other Fischertechnik education solutions. We have a lot of great products right on the Studica website, and the address for that, for the Fischertechnik section, is www.studica.com/Fischertechnik, FISCHERTCHNIK Just go to our website and you can bring all that up and all the information, or you can email us directly. For quotes and pricing, you can again email us at info@studica.com, info@studica.com, and we'll get that information right to your dedicated educational rep. Or if you would like to email me directly with any questions you might have, anything I've talked about today, or anything you'd like me to touch upon, I will be happy to do so with you directly. My email address is lance.zurich, LANCE .z, like zebra, UREK, @studica.com. So just feel free to email me directly and I'll be happy to help you out. So once again, thank you very much for attending. Have a great day, stay safe, and we look forward to talking to you soon. Take care.